We are entering the home stretch now. It's been rather a long chapter, and remember that the test is going to be next week. I'm giving it to the face-to-face students on Tuesday and Wednesday, which means just sometime next week, if you folks could come in and take that, that would be awesome. Just let me know when you need to do that. I don't care when you do it, anytime, Monday, Tuesday, or Wednesday. It's a 2-day test for the face-to-face students because it's just a longer test. If you want to do it in 2 days, you're more than welcome to. If you want to do it in 1 day, it probably will take you about 75 minutes. So plan on about a little more than an hour for the test if you want to do it all in 1 day. Just let me know what you need and what you're doing with that, and we'll get you accommodated. All right, the last thing that we have to cover is power. And by definition, and the reason why we fit it into this chapter, is that it is the ratio of work done to the time required to do it. So we've got work going on. The ratio of work done to the time it takes to do it. Another way you can say it is the rate of doing work. And as a formula, that would be power is equal to the change in work all over the change in time. How much work over how much time? How much work over how much time? Also, though, it can be defined as the ratio of a change in a form of energy. Again, to the time it takes. And you can say the same thing as we did here. It is also the rate of changing energy, changing the amount of energy. Not changing energy from one form to another, the rate of changing the amount of energy. Another way we can put that then is P is equal to delta E, and it can be any of the forms of energy we've talked about all over delta T. So it could be delta PEG, delta KE, delta PES. That's not one I've seen before, or delta E thermal. Again, that's not really one I've seen before because it's not like that's something you would want to do. That does not look like a P. There we go. Let's make that look like a P. Now the units for power, if we take the units right out of the formula, it would be joules per second. But joules per second is actually the definition of watt. So 1 joule per 1 second is 1 watt. Let's go ahead and give this a little try here. And I have this written out for you. A crane lifts 300 kilogram load. Make sure it's 300 here. Crane lifts 300 kilogram load at a constant rate of 1 meter per second. Calculate the rate at which the crane is performing work. So I'm doing the work equation rather than the change in energy equation. So I have to figure out, since work is force times distance, and so my crane is lifting the load up, and it's lifting it up at a rate of 1 meter per 1 second. So let's work through what the force is. If it is moving at a constant speed of 1 meter per second, then I don't have any acceleration. If I don't have any acceleration, then the force of pulling it up must equal the force of it being pulled down. So work is equal to force times distance, but the force has to be equal to the weight. Or another way of saying that is the force is equal to 300 times 9.81, which is 2,940. Oops, I'm off the page here, I'm sorry. 2,940 newtons. Okay, so my force is 2,940 newtons. I have to figure out what my distance is because work is equal to force times distance. I also have to figure out what my time is. So I'm going to look back at what I have here, and it's a rate, 1 meter per second. So if I decide to make my time 1 second, then my distance is 1 meter. If I decided to make my time 10 seconds, then my distance would be 10 meters. So they're all, as one increases, so does the other one, and that's going to make my numbers work out exactly the same in the problem. Because then I have power is equal to force times distance over time. Power is equal to force times distance over time. So if I increase this by 10 and I increase this by 10, what I was talking about here, 10 seconds would give me 10 meters. Well, that would just cancel out anyway. So it doesn't matter as long as I keep the rate the same that I was given here, 1 meter per second, 10 meters per 10 seconds, 100 meters per 100 seconds. Doesn't matter which one I use. I'm going to end up with the same answer however I do it. But we actually do really like to use simple numbers. So I'm going to make my distance 1 meter and my time 1 second. So it ends up being 2,940 newtons times 1 meter all over 1 second, which ends up being 2,940. This is a joule, so it's joule per second. A joule per second is a watt. 2,940 watts. Now there's something kind of interesting with this that I'd like you to see. When you look at this equation, what I really have when I'm doing work is P is equal to F times what is distance over time? Distance over time is another way of saying constant velocity. So I actually have then power is equal to force times the speed that I am applying the force to the object. And sometimes it's given to you that way. So by 1 meter per second could actually be 1 meter per second. And now I have a velocity, which I actually could put in here and it would work. It actually works for some of the other energy equations as well. If I have P is equal to delta PEG over T, then I really have mgh over T. mg is force, force is weight. I'm sorry, mg is weight, weight is force. So I would have force or weight times distance over time, velocity. So sometimes you will be given something that looks like velocity, and it actually does work with this. It works with the delta KE, but it's kind of funky how it looks. You end up with a half in it, and it's much harder to pull the velocity piece out of that because there's already a velocity piece put into it. So that one gets kind of complicated. You can do it, but it just looks weird. But it actually is possible for these too. You'll notice for this one, they didn't give it to you as a speed. They just told you it was 1 meter per second. So you could have just done it as distance over time. I just wanted you to see that there's that built into the power equation. All right, that's it. This is short and sweet. We didn't have a lot to cover today. Your homework is on the side here, 63, 65, 67, and 68. Like we did here for number 63, you can just make an assumption about time and then take it from there how you want to do it. And for number 68, you're going to want to use the work, power is equal to work over time, and then just kind of logic your way through the rest of it. This will be due on Monday. I would like it by Monday. If you can get it to me sooner than Monday, that I can get it back to you before the test. So, but it is going to be due on Monday so that I can have a good turnaround time for you for the test. All right, that's it. Holler if you need anything. Certainly give me send me an email if you're not understanding these problems at all. All right, have a good evening.